afternoon. If you've joined me today, or joined me on any day, you're here to learn how to use the equation of a circle, which is like a level 9 skill in GCSE. Knowing about it is also useful in A level. So you're on the way to learning the A level material, as well as being on the way to understanding it for the higher tier GCSE. Let's go straight in, not waste any time. So let's get started. So we know already that a quadratic equation normally takes the form something in the region of y equals x squared plus 2x plus 5, for example. Now, anything with an x squared we know has a shape that looks like that. If we inverted that and instead said x equals y squared plus 2x plus 5, the effect, plus 2y, not 2x. The effect would be to instead have an equation like that. Now, I'm well aware I've drawn this incorrectly. If you wanted to be strict, it would need to be a different place. I'm more trying to demonstrate the equation, but let's be accurate. It would be more like this. And this one would be further over as well. But my point is not that that's what it does. It's more, if we combine them and make them both x squared and make them equal to a number, for example 49, it was discovered that this would create a circle around the centre. So you've got this curve going on here, the curve going on here, but if you have an x squared and a y squared equals a number, it creates a circle. Not only that, the radius of that circle I know would be 7. And the centre I know is 0, 0. For this is the stuff you need to know for GCSE and for A level. And this is because if I remove the earlier stuff we were talking about, what the basic premise is that if we've got x squared plus y squared equals a number squared, we square root the number and the radius is r. However, we can even change where the centre is, and that would be done with x minus 3, for example, plus y plus 2. This links to the lesson on transforming equations. Because it's in the brackets, it goes the opposite the way to you'd expect, because it's happening to the input, not happening to the output. So this would go down 2, and this would go to the right 2. So what this would effectively do is it moves the circle to 3, sorry. This moves the circle to 3, 2, centre. No, it doesn't. Mr. Harris, you clearly said go down, so 3 minus 2 would be the centre. And then the circle is drawn round. And let's just be considerate here. This is 16. So this would be a radius of 4. So it's important we understand that the radius is the square root of the number on its own, and then you need it in brackets. Anything on the outside beyond that, and it ruins the circle. And this is where you'd start to get egg shapes and things. If you wanted to play around with it, you can get ellipses and all sorts of weird circles. But for it to be a pure circle, it needs to be a square plus a square equals a square. Now that number doesn't have to be a square number here. It could be, say, 12, and we just go the square, whatever the square root of 12 is, which is like 3.4. So it doesn't have to be a square number, it doesn't have to be exact, but this will tell you the format. Well, how would we go about this? Well, I'm going to use this first of all to do an exam style question. So here's an exam style question based on our knowledge of the equation of a circle. The equation of a circle C with a centre O is x squared plus y squared equals 25. This tells us from what I've just said that we've got the centre of the circle. There is no brackets with the x. There's no x minus or x plus or y minus y plus. Therefore, we know it's at 0, 0. The circle itself is around 0, 0 if there's nothing as a bracket going on. Then, the radius is going to be the square root of the 25. So the square root of 25 is 5. Therefore, that's why that's 5. I understand fully that this could be minus 5 because the square root of 25 is also minus 5, but the radius is a whole number, therefore we just go for 5. Now, finally, to show the point 3, 4 lies on the curve, we have to remember that every coordinate exists as an x and a y. So all we need to do is show that this left-hand side will make 25 if we put those numbers in. So we take our x squared plus y squared, we put in the x value, put in the y value, that gives us 9 plus 16, which is 25. I apologise if you can hear screaming. My child has decided that now is the time it wants to scream the house down because milk apparently is not being plentiful enough. So we have, that proves it's 25, so we've shown that it's on the point thing. But if you're ever asked a show question, finish it by stating, so 3, 4 is on the line. Always finish a show that question with a sentence of what you have shown. This is what I want to be shown. This is my working of showing it. This is this, so therefore this is this, this is this, this is this, so therefore 3, 4 is on the line. It's just the standard of explaining. This is what this shows. Don't let any wording from the question be part of your answer. Now, how would I go about it if it wasn't very neat? Well, occasionally, this is more A-level, but it's certainly useful to understand here. Let's imagine we had x squared plus 4x plus 4 plus y squared equals 0. Not 0, that's not going to be useful, 100. We haven't yet got an equation of a circle. However, if we group that stuff together, that makes the bracket x plus 2, x plus 2, which hopefully you can all see is equal to x plus 2 all squared. So therefore we do have x plus 2 all squared plus y squared is 100. We now have a square with the x plus a square is equal to 100. So we would have centre, it's going to go backwards 2. So the centre is going to be minus 2, 0. This has not got a bracket, so it's just 0. And then the radius of the square root of 100 is 10. This is going to be the circle. And so we can draw it. We go minus 2, 0. That's going to be 8. Nice big circle. Not the best circle I've ever drawn, but hopefully you can see what I'm talking about. And that would be 10. That distance there. And that would be, that bit there would be about 10. Okay, so we're just trying to show that the circle you can actually manufacture from the thing. You can even sometimes have to do some tomfoolery. For example, x squared plus 6x plus 10 plus y squared plus 4y equals 50. When doing this one, what I would do is I'd use that bit and I'd use this bit to complete the square in each case. This makes x plus 3 all squared. If you're not clear on completing the square, go and watch my video on completing the square, or go and watch a video on completing the square. Then the leftover is minus 9. Then we have plus 10, because that hasn't been done. Then we have y plus 2 all squared, minus 4. You always have to take away the number squared. equals 50. Now tidy it up. X plus 3 all squared plus y plus 2 all squared minus 9 plus 10 minus 4 is minus 3. Therefore, that equals 50. Now we can add the 3 on. So x plus 3 all squared plus y plus 2 all squared equals 53. So what we've done is we've now got it in the equation of a circle form, because we have a square in x, a square in y, and a number. We are then able to state confidently that the radius equals the square root of 53, which is approximately 7.2, and it might be 7.3. And then the centre, this is going to go backwards 3, this is going to go down 2, so the centre would be minus 3, minus 2. So what I've tried to teach you today is that the format of a circle is you get an x squared plus y squared equals r squared, but you may need to adjust and use completing the square. Completing the square is more of an A-level skill. The GCSE skill is more like the ones I've just done there. Now in the description below there is the Corbett Maths worksheet on the equation of a circle where you can practice some of these skills. This question is adapted from one of those. I just changed the numbers so you could still think for yourself and do those questions. I recommend going away once you've watched this video, practicing that skill over and over, and doing all the questions and making sure it's clear. Then you can come back and ask questions if there's anything you're confused on. You can email me if you're struggling with any of it. But again, it's not about necessarily watching this lesson live. You could be watching this lesson as a revision for your GCSE. You could be watching this lesson in a year's time. The whole purpose being, if you can understand how this works, you then need to go away and practice it to get better at it. I hope this has been informative. I don't intend these higher tier lessons to be particularly long when it's a new skill like this and you need to go and practice it. But please don't consider yourself that this is over, that you've completed the lesson, because to complete these lessons that I do for higher, it's about doing the practice makes permanent. You won't recall this if you watch the video and then come back in 6 months' time. What you need to do is now practice the skill by using the worksheets in the link below. If you're doing this as part of a homework, maybe you watch this video because you're stuck on a homework, then do the homework that you've been given at school to practice it. But hopefully this has helped. I will always answer questions if anyone posts them below the video. Thank you very much for joining me. I've been Mr. Harris. You haven't. Take care.